how's it, guys? Welcome back to the channel. I hope you guys are doing well. I have been thinking about time for quite some time, ever since I started making these observations and I needed to find out the exact time of sunrise and sunset, the moon, Venus, etc. I thought, why don't I make a video about it? This is obviously a very deep topic because time is not really understood by everyone or anyone, and we go according to what we can measure. So we use the Earth's rotation, which is 23 hours, 56 minutes and 4 seconds. So we use a 24-hour clock, but there's also something called a sidereal day, which is the time I mentioned before. So with these two times, we see the difference in where the sun appears in the sky at any given time of the day. It does bug me a little bit when I hear people talking about the Earth being 6,000 to 10,000 years old, when there are experiments. Researchers have taken the time to look at what the rocks are made of and how old they are. And when they do the radiometric dating, they find that some of the oldest zircon crystals in the world are about 4.4 billion years old. And we have sent craft out there into space to rendezvous with objects out there and collect samples from them and bring them back to Earth to date them. And we find that the solar system is about 4.54 billion years old, give or take 50 million years. Now, I don't know how far what I'm about to say is true, but we look at things from Earth's perspective because we are on Earth. If we were on the moon or somewhere else in the solar system, I would bet quite a lot, if I had it, that time would progress differently, or we would experience time in a different way. So I decided to do some fringe mathematics, if you can call it that, and I made a little table to see how much differently we might experience time if we were on any of the other 7 planets and 1 dwarf planet. I didn't work it out for the moon because essentially the moon is part of the Earth as we orbit the sun. We orbit the sun as one unit. I've listed the objects, the orbital periods. I've converted the years into Earth days, and I've done the orbital velocity in kilometers per second, the rotational period in days, hours, and minutes, and the rotational velocity in kilometers per hour. Then I converted the orbital period of the other objects to the duration of Earth's orbital period, which is 365. I did this generally and I rounded most of the numbers off, and I took the age of the Earth as 4.5 billion years. I just rounded it off. I know that there are more precise numbers. And then I calculated what the time would equal to if we were on those other objects experiencing the solar system. So, given what we know about orbital mechanics and how the planets move in the sky around the sun. And we know about time dilation and relativity and the speed of light. And now we may have inklings that some parts of a black hole, time may even reverse. So, if time is such, I don't even know what the word is. If you are on a different place, you'll experience time differently, whatever you call that. Then you take all of that and you shrink it down to 6,000 to 10,000 years. I just cannot understand that perspective. So we are cross-checking our work all the time. And when we look at the numbers, from Earth's perspective, things are 4.5 billion. And just to illustrate my point, I took these 3 screenshots from timeanddate.com. I like to be consistent with my observations and the data I provide. So my GPS is constant, so I can get consistent results. And as you can see from these 3 screenshots, it took about 2 seconds to have that 0.01 degree change. And from my observations and the data I've collected, the shift of the sun in the sky does not take the same amount of time throughout the year, which means we experience time differently depending on where we are in our orbit around the sun. And additionally, we will experience time differently depending on where we are on the Earth, southern hemisphere, northern hemisphere, equator, or poles. And that is demonstrated by the fact that we have different amounts of daylight and darkness depending on where we are on the Earth and which part of the year we are in. And that's why we use the consensus of 23 hours, 56 minutes, and 4 seconds to keep us all in check. That's it for this video, guys. If you've made it this far, thank you so much for watching. Please comment, give the video a like, subscribe to my channel, and ring that bell. And if you might be so inclined, please support me on PayPal. If you would like to discuss any of my observations, please join us on Discord. Please, guys, stay safe, and I will catch you in the next video. Bye.